Today we're going to have a lot of fun. We're going to build a model of an aquifer. We're going to get our hands dirty and learn about the water cycle as well. The water cycle shows us that water on Earth is warmed by the sun and evaporates to rise high into the atmosphere. The water vapor cools to form clouds when it is far from the warming effect of the Earth. The water is recycled on Earth when it rains. We rely on having enough water to live. When rain falls, we see it gathering in lakes and rivers, but they only cover a small percentage of the Earth's landmass. What happens to rain that falls on land? Are we able to access that for our use? Today's demo on how to build an aquifer is linked to OCWA's OneWater Education Program. If you are participating in this program, please refer to the aquifer section in the workbook. If not, please enjoy this video as it best suits your learning needs. Hi, my name is Christine. I work at the Ontario Clean Water Agency. We operate and manage water and wastewater systems across the province. I'm a PCT, which stands for a Process and Compliance Technician. I'm part of a team that helps to make sure that the water coming out of your taps is safe to drink, and the water being returned to our lakes and rivers meets the highest environmental standards. I'm here today to demonstrate how to build a model of an aquifer and show you where rainwater goes when it falls on the ground. Did you know that 30% of the Earth's fresh water is buried underground in aquifers, only accessed through wells? You're probably wondering at this point, what the heck is an aquifer? An aquifer is actually a collection of wet, underground rocks that allow water to pass through them slowly. Think of a rock as a sponge. Water fills small holes and cracks within the rocks, sand, and stones that make up the aquifer. These small openings provide spaces for the water to move through slowly, much like a sponge allows water to pass through it. Aquifers are important because they are the main way people get clean, usable water. So let's get going and build our aquifer. This activity helps us answer some of the following questions. Where does rain go when it falls on land? Does it disappear? Is it collected somewhere? How can we find out? Can we access the water that falls in our land for our use? These are the materials that I will be using to build the aquifer. You'll need a clear plastic container, a cup with some small holes, small peat-like stones, white ones are ideal, tubing and a syringe, colored water, I've got 2 batches here, one blue and one yellow, and a notebook or somewhere to record your observations. If you are following the OCWA OneWater Education Program, use the aquifer inquiry sheet in your student workbook. You could also choose to have some soil and grass clippings on hand to layer over top of the stones, and also some molasses for the last step of the experiment. Today I'm using colored water, so you can get the clearest look of what's going on in the aquifer model. If you don't have tubing or a syringe, don't worry. There are many items you could use. A turkey baster, an eyedropper, or your spray nozzle will all work nicely. When we start building our aquifer, other substitutions may become clear to you. Be creative and have fun. All right, so first we're gonna grab our plastic container and our stones. We're gonna put our stones in the plastic container. We're gonna slope our stones to the one side to form a hill, so a lake can form on the other side of the model. If you have soil, layer that on top of the stones and pat it down to minimize erosion. You can also add grass clippings as well to symbolize vegetation on the side of the slope. So now we're gonna make it rain. So grab your cup with holes in the bottom, and we're gonna grab our colored water, and we're gonna pour it over the whole model. Refill as needed. So you're gonna wanna stop when your lake is a few centimeters deep. This is especially important if you've decided to use grass clippings or soil. We don't want to turn the model into a swamp. This is a great place to take a break, so you can record your observations about what happens to the rain as it falls onto the model, and how the lake is fed with water. Feel free to pause the video. I'll be here when you get back. Welcome back. Let's get back to building our aquifer. Look at the water table, the top of the saturated level. The water table fluctuates depending on how much water enters into or is discharged from the aquifer. The water table rises the more rain that falls onto the model, and the water table falls when the more water that's removed from the system. Groundwater is used extensively for drinking water and irrigation. To obtain the water, a bore is drilled deep enough to penetrate the water table. To simulate this, I'm going to use my tubing and I'm going to work it into the side of the hill down to penetrate the water table. So now I'm going to attach the syringe to the tubing to simulate a well pump. So now we're going to draw from our aquifer. Okay, now pour the yellow water, or if you have molasses, this is where you can use that. Although warning, that can be a bit messy. So pour your yellow water or molasses onto the model. Record what happens. How does this affect the water underground? How does this affect the lake water? What do you think the yellow water or molasses could represent? What do you think it simulates? Let's take a minute to record your thoughts. So what did you come up with? Did you notice that the yellow water or molasses made its way down to the aquifer and to the lake? This could stimulate contamination, whether it be biological or chemical. You'll notice that if you try to pull the water from the aquifer again, that it's a different color. It changes to a different color, blue or green, depending on your colors. Now that we've built our aquifer and understand how it provides us with a source for water, let's find out what happens when the natural water cycle is interrupted. Can you think of what could cause this and what the consequences could be? What are some other factors that could contribute to changes in the aquifer levels? Why do we need to protect our aquifers? Take a minute to discuss and research. What did you come up with? An example is drought. If we keep drawing the water from the well, the water table will get lower if it's not given time to recharge. Eventually, you won't be able to pump any water. Flooding is another good example. Flooding would cause any contaminant on the land to run off into surface water and eventually contaminate the groundwater in the aquifer, just as we demonstrated with the yellow water. Another example is population. In big cities, there are large areas covered with concrete, not allowing the rain to penetrate on the ground and recharge the aquifer. That's why green spaces are so important in cities and towns, or new technologies aiding in recharging aquifers. These are some big questions. There's a lot you can do in your own community to help protect your water sources. Feel free to discuss these ideas with your classmates, friends, family, or your community. Thanks so much for tuning in. I hope that you learned something today, and that next time you think about where your water comes from, you'll have a better understanding of what's happening underground.